Right now I'm going to get into pointers and arrays and show you guys how they're related with each other. First of all, when we declare an array, for example, such as double address, we first start off with the type, and then the name of the array, which is the address, and then put a value inside. That's one way of declaring an array. We can also declare an array this way. We can also do double, name of the array, and use address this time. And we don't have to specify any allocation. We can just go right on into giving it the values. So we can give it like 2.2, 4.5, 1.9, all separated by commas inside the French braces. And what this will happen is it will give it a default value of 3 if we have these three values inside, 2.2, 4.5, and 1.9. And we won't need to specify the size. If we specify the size, we'll get a compile error. So all we need is those two empty square brackets, and then we put in those values. If it was a string, or sorry, a char array, then we have to put them in single quotes, each of the values. So separated by comma and single quotes for each value. Now the reason why I call this address is because I was originally talking about pointers, and you know about pointers, they all have to do with an address. In order to store the address of a variable type double in a variable named address, we can write double asterisk address. You may attach that asterisk operator to the type of the identifier or both. So many C programmers, we like to put it right beside the double. I talked about this before. We can actually get the address of an array, right? And we can use pointers in order to edit each of the indices of the array. So for example, let's say I have an int array, okay? Int array, let's not give it a size. Let's just put those two square brackets and then some French braces, right? So equal sign in the French braces. Let's put some numbers in there. So I'll put 1, 3, 5, 7, 9. Okay. Using my method of pointers, I can assign a pointer to the first indice of the array, which is the array at 0. The way of representing the first indice of an array, we can either do it two ways. We can do array at 0, okay, or array. That is the exact same reference point. We're referring to the first indice of the array. But in the case of pointers, the address of this array is just the name of the array itself, without any square brackets included, without any indice specified. It's just the name of the array itself, which is array in this case. Before we get into pointers and arrays, in order to send an array to a function, we can do it either two ways. So say we have int change, right? And we want to accept an array. Just say it's an integer array and it's an integer function called change, okay? So we have the int change, okay? We put the int change, and then we put a bracket. The type of the array, let's just say it's a char. Let's put a char array, okay? For simplicity, it's char, and then the identifier, which is the name of the array. One thing to note, when you're sending an array to another function, make sure to have those two square brackets. You don't have to specify the address, because as I said before, array with two square brackets is the address. Same with array, okay? You can send the array itself, the name of the array, which would be array in this case, or you can send the array with two brackets. It's the exact same thing. I'll even type this out for you. Int change, right? Char array, that's it. Okay, it'll do the exact same thing. Now the function header for this, for one thing, when you are using the array itself with no square brackets, make sure to have it pointed, because that's the only way the program will know that you're sending the address. And when you instantiate that function call, you have to use the ampersand because you're setting the address. When you use the square brackets, that's basically sending the address right off the bat for you, and you're able to accept it without having to dereference it with the asterisk. But in this case, you can use the asterisk Makes it look a little bit cleaner, you know. Helps you in that respect. Okay, the function header. Okay, simple enough. So int change, right? Char asterisk in the second case. In the first case, int change uh, char and then a space and then 2 square brackets. Okay, that's how you do the function headers for each of the 2 functions. You don't have to specify the name. You can have a space between the asterisks and the name of the array. You can actually access certain area of the array, certain indices of the array using purely pointers. For example, I have this int array up here with the values of 1 and 3, 5, 7, 9. Okay. Now let me make an integer pointer. Okay. So I'm going to make an int asterisk ptr. Okay, and give that initial value 0 just for now. It's always good to just give it an initial value of 0 because that way you know what's happening with it. It's just nullified right off the bat, so you don't have any lost data or anything. Just keep it at 0 right off the bat until you assign it to something. Sometimes you want to assign it to something and then you'll have memory leakage or something will happen with your compiler. So after you assign it to 0, give the predefined values. You make ptr, okay, equal array. Ampersand, actually not ampersand this time. Okay, you don't need the ampersand this time. My bad. You do not need the ampersand because array itself, okay, because we called our array, right? It's a pretty dumb name, but ptr is equal to array. If we were to print out right now, let's print out array itself. Okay, let's print out array itself. Okay, you see array itself has its address. That's the address of array. Array by itself, the name of the array by itself, if we were to print that out, we just get the address, okay? What does that tell you? That tells you that you don't need the reference operator, we don't need the ampersand in order to find the address, because array itself is the address. So we can make the pointer, right, hold that address itself, so we can do pointers equal to array. So the pointer now knows where array is located, the first index is located. That first address you see is where the first index is, so that would be 1 in this case, since our first index is 1. So once we do pointers equal to array, just like that, what we can do is we can access the next number through the pointer. So if we were to do asterisks, right, we would do a cout over here. Do a cout, right, an asterisk, and then a bracket, and then an, for example, let's do ptr plus plus or ptr plus 1 for simplicity's sake. If we were to do cout ptr plus 1, it would go to the next value in our array, right, and print that out. Because what we're doing is inside the brackets, right, these brackets are key because it only dereferences the value once we know what index we want to touch. Initially, ptr, right, is the address of the first index, right? We want to jump to the second index, we add 1, and then the compiler knows what address we want to dereference. Then we have the asterisk. So then it's dereferenced. We don't want to do something like this. We don't want to do asterisk ptr plus 1 with no brackets. We need brackets. We need to dereference after the fact that we've established what index we want to touch or access. As we know, asterisk ptr is the first. That's the first index. Okay. Just understand that yourself, and then you understand the fact that the first index always gives us the address, and then it helps you a lot with the later on when we start going into memory allocation and other stuff.